Example 5 from 4.1. Find the inverse of f of x equals 3x plus 8 and state any restrictions on this domain. So, first of all, if you look at f of x, which is 3x plus 8, and if I establish the domain of this function is the set of all real numbers, because I can multiply anything times 3, and I can add anything to 8. So there's no restrictions as far as putting numbers into this function. As far as the range is concerned, if I just imagine the graph of this, y equals 3x plus 8, it's going to be a line with a slope of 3, y-intercept of 8, so it's going to go all the way from negative to positive infinity on the y-axis. So all real numbers. Okay. If you recall what an inverse function is, or what it means to be an inverse function, you have an ordered pair x, y in the function, the ordered pair y, x is in the inverse function. So the x and the y swap places. So what I'm going to do to create an inverse function, I'm going to save this for later. All right, so we'll just worry about that in a moment, but that's important as far as the restrictions on this domain part of it. All right. So if I go to the function f of x equals 3x plus 8 and rewrite it as y equals 3x plus 8. Anytime I want to do inverse functions, I like x and y instead of f of x and x. All right, so x and y, it's just a little bit more straightforward as far as I'm concerned. To make an inverse function, we do exactly what an inverse function is. You swap the x and the y. So where this says y equals 3x plus 8, x equals 3y plus 8 is the inverse function. And that's the inverse function right there. But they do want us to get it to the y equals structure, so we want to solve. So I'm going to get, if I move the 8 over, I'm going to get x minus 8 equals 3y. Divide both sides by 3. This y, which is the inverse y, is equal to x minus 8. This is the inverse x, right? So as far as writing it in good inverse function notation, I'm going to change this y into an f negative 1x. So my f inverse of x equals the expression that's over on this side, which is x minus 8 over 3. If you want, you can make it x over 3 minus 8 over 3 also. That's fine. They're both correct. This is the inverse function, so that's the task there. Now, domain's all about x, range is all about y. So if we're making an inverse function, we're going to flip-flop the domain and range. So the domain of this is the same as the range of that. So the domain of this is a set of all real numbers. So there are no restrictions on its domain, as you can see. Obviously, if I'm just looking at this function just on its own merits, I can subtract a from anything, and I can divide anything by 3, so there's no restrictions anyway because of that. But just know that sometimes an inverse function might have some no restrictions, but based on its original function has restrictions. So that's why you want to go back to the range of the original function to establish the domain of the inverse